Okay, so some of you have used Maple before, but some of you haven't. So I'm going to give an introduction, and this is also a good review for those of you who have used it, but it's been a little while. So first, just the basics. Defining an expression and defining a function in Maple. So if we define something, and I'm going to use the variable there, so it says f of x, y, so I'm going to call it f. Whenever you want to define something, it's always colon equals, not just equals. It has to be colon equals. And then if we're defining an expression, we just start typing in the right-hand side. Now, the new Maple isn't quite as picky, the newer versions, but in general, it's just good to get in the habit of always using operational symbols. So instead of just typing 3x squared, type 3 times, and that's just the shift of the 8 key, x squared, and to get it squared, I just do shift of the 6, and then minus 5 times x times y. If you just type 5xy, there's a good chance that Maple will think of xy as one variable, because sometimes I'll define an expression as a whole word, like maybe I'll call it tangent line or something. So it doesn't always see every individual letter as its own variable, because sometimes an expression is defined as a whole string of variables as a word. So it's best to use operational symbols if variables are separate. And then plus 6 times y. And then you're supposed to end a command with the semicolon, but if you don't, sometimes it'll give you a warning, inserted a semicolon at the end, and then just press enter. Okay, and so that means it's defined the expression. Now I'll define the function in a second, but I'm going to go down to the evaluating the expression. And just to clarify, you should be doing all of this as I do it in the video. So I don't just want you to do the problems at the end, because I want to know that you've gone through this exercise. Okay, so here it says evaluate the expression at the point 1, -5. So if we're evaluating that expression, we're substituting those numbers in for the variables. And the command to do that is subs for substitute, and then parentheses. Oh, Maple is also case sensitive, so don't do a capital S. So SUBS. And then I'm going to substitute in x equals 1, comma, y equals -5, comma, and then tell it what you're substituting into. So I have already defined that expression as f, so I just put comma f. So I'm substituting x equals 1 and y equals -5 into f, close parentheses, semicolon. Okay, and then I get -2 when I do that. Okay, so I want to talk about how it differs when you define a function. So if you define a function, start out the same way. I'm going to call it g this time. So g colon equals. So it starts out like defining an expression, but this time when it's a function, then if it was just a function of one variable, then I would do x minus sign, and then I'm going to do shift of the period, which is the greater than sign, and as soon as I do that, it's going to turn it into an arrow. So if I was doing just g of x equals 3x squared plus 5, then I would do colon equals x arrow. Now, since I have a function of two variables, though, I'm going to put x and y in parentheses, and then minus shift of the period key. And now it's the same exact thing I typed before. 3 times x squared minus 5 times x times y plus 6 times y. And then semicolon, enter. Okay, and so there's our function. So now if I want to evaluate, if I've defined it as a function and I want to evaluate it, we don't use the subs command anymore. I want to show you what happens if I do that and say g. Well, it may work. Yeah, but okay, I was hoping it wouldn't. Okay, so it just gives me g back. That's because if you type it like this, it's thinking of g as an expression, but I've defined it as a function. So you have to be careful and pay attention to how you define things, whether you define them as expressions or functions. So how you evaluate a function is just exactly how you would write it on paper. So it's g parentheses 1 comma -5. That's how I would write it on paper, and then enter, and I get -2. There are some advantages to defining things as functions and or sometimes as expressions. But I just wanted to make you aware that there are two different ways of doing things. Okay, solving an equation. So the command for solving is just the word solve, but again, case sensitive, you can't use a capital S. It's just lowercase solve. And so I want to solve this, which is the same thing. I've already defined f to be the left-hand side of that. So I can say solve f equals 0. But the problem is in that expression, there are two variables. So there's no way Maple knows what you're talking about when you say solve. You have to tell it what you want to solve for. So I could solve for x and then semicolon. And it would use the quadratic formula, see, and it gets this expression. You could also solve it for y, and it would be a similar, so it didn't have to use the quadratic because y is never squared. So just when you give it an equation to solve, tell it what you're solving for. Okay, differentiating an expression. So I want to take the derivative of that expression with respect to x. The command to take a derivative is diff, and I've already defined that expression. So I want to differentiate the expression f, comma, and then tell it which derivative or which is the independent variable. So here I said x, semicolon, and then I get that expression. Now, if I want to differentiate the function, the command is still diff. But if I do just g comma x, it's going to give me 0 because g is not an expression. G is a function. So I would, if I want it to take the derivative of a function, I have to refer to it as a function in the command. So diff g of x comma y. Okay, and so then I get the same thing. So just, again, trying to stress, you need to pay attention to whether things are defined as functions or expressions. Evaluating integrals, so they're indefinite and definite integrals. So here, suppose our integral was 1 over, or we have the integral of 1 over 4 minus x squared. The command to take an antiderivative is int for integrate, and again, case sensitive. And then you type in the function, the integrand. So 1, and then I'm just hitting the slash, and it's all automatically going to turn it into a fraction. 4 minus x squared. And then after the expression, so if you, like there, you're still in the exponent. I'm just hitting the right arrow to get out of the exponent and the right arrow to get out of the denominator. And then comma, you have to tell it what variable to integrate with respect to. So I want to integrate with respect to x. Okay, and then it gives me, it won't, Maple will never add the constant at the end. So just keep that in mind if you ever use it to find an antiderivative. Okay, so evaluating a definite integral. So it still starts out with the same command, int, and then you type in the integrand. I think it's okay if you do cosine squared of 4 pi x, but I always put the square on the outside. So I'm going to do cosine parentheses 4 times, and then to get the pi, it's capital P-I, case sensitive, capital P-I times x, close parentheses for the angle, close parentheses for the cosine, and then square it, right arrow to get out of the exponent, comma, and then your independent variable is x. Now you're going to give the limits. So x equals, and then it's always lower limit dot dot upper limit. So 3 dot dot 8. And then close parentheses semicolon. Okay, and then we get our answer 5/2. I just want to show you that if I had done lowercase p, it doesn't work. It only puts in the symbol. It doesn't think of it as the actual value pi. So there it's just putting the Greek letter. So if you want it to actually think of pi as a number, you have to call it the capital P. I should have done something with the exponential function here. If you want to use the exponential function, you have to do exp. So I'll just do one here. So I'll do the graph that I just talked about. But if you want to plot the exponential function, or let's even say evaluate or integrate the exponential function. So if I go up here and I do int, and then I do just e raised to the x, comma x. So it gives me this. It's not thinking of e as the actual number. So in order to get it to recognize it as the exponential function, you have to do exp parentheses. Just like if you have a graphing calculator, when you do e to a power, your calculator puts exp parentheses on the screen. So now if I do it, I'll just get e to the x. Okay. So if you ever are dealing with the exponential function, it's exp, lowercase exp. The help menu is really good. You can get examples of how to type in functions. I'll just bring that up quick. So if you were looking for like how to use the exponential function, let's see, over here. So here it gives you examples of commands, and notice every time it uses the exponential function, it has exp. So if you're having trouble, first, I would strongly encourage you to ask me. I have a lot of experience with Maple, and I'm more than happy to help. But if it's late at night and you're working on this, or it's on the weekend when I might not be checking email, go to the help menu. The help menu is pretty good. Okay, so now I'm going to go back to what I want you, I think how Maple will be most useful in this class is with plotting, because we're going to be doing lots of things in 3 dimensions, and sometimes it's hard to visualize since this is your first time maybe dealing with functions of more than one variable. So first I'll just do plotting in regular 2-dimensional space. So I want to produce a graph of this cosine squared of 4 pi x. So you can define this as a function and then say plot the function, or you can just go to plot. That's the command to graph, and again, no capitals in there. And you can just go type in the function. So I'm going to type it in the exact same way I did in the integral. So I'm going to square outside of the parentheses cosine of 4 times pi times x, and then square it, and then comma, and then tell it what your variable is. Okay, so that's kind of a crazy looking graph. I do want to show you what will happen though if you didn't capitalize the pi here. You get nothing. Warning, unable to evaluate, because it's not thinking of this pi as being a number. It's only thinking of it as the Greek letter. And also, if you had done that like with the exponential function, like say you said plot e to the x, it's going to do the same thing. Because it's not thinking of e as the number, you would have to do exp of x, and then it will graph. Okay, so I'm going to go back to getting the plot of this. Okay, and so I said that graph doesn't really look so great. Maybe if we changed the region or the interval for which it was plotted, it would look better. So it says, I just want to see the graph on the interval -2 to 2. So I just want to see a small piece of that. So I'm going to copy and paste this command. And then instead of just saying plot it with respect to x, here is where I give it the interval. And we do it the same way we do for definite integral. X equals small number dot dot big number. So x equals -2 dot dot 2. and then enter. Okay, so now it's a little better. You can also specify a range with y values. You could say comma y equals -1 dot dot 1. Oops. And then, so you can specify both the domain and the range in your plot command. Okay, so that one was, we just had the right-hand side, like y equals, and then the right-hand side was completely in terms of x. If they have it, so an equation that's not solved for y, like this one we could solve for y and get 2 answers, but we can also plot an equation that has both x and y in it. And the command is implicit plot. And then you type in the equation, so x squared over 9 minus y squared over 16 equals, whoops. So there, so look, I typed that equals 1 in the denominator. I'm going to delete that and then hit the right arrow to get out of the denominator, equals 1. And then with the implicit plot command, you have to give values for both x and y. So x, I'm just going to go from -5 to 5 on both of them. We can always fix it and adjust, whoops, -5 dot dot 5. Close parentheses, semicolon. Now, this is not going to work. I'm going to get a command back. It's just going to type in blue what I just typed in. If that ever happens, that you just get exactly what you typed in back, then that means there's some menu that you need to call up. And for plotting, so like if you went to help and did implicit plot, and I'll just type in implicit. So there's implicit diff. So in your Calc 1 class, you should have learned about implicit differentiation class. Now here's implicit plot. And when I go down to this is all just talking about the things you can do. I always just scroll down to the bottom where I see commands, which are in red. Okay, so here is the command you need. And actually, you don't need to type in the implicit plot. You can just type in with plots. So to get an extra place where you can type a command, I should have talked about this at the beginning. If your text is just, regular typing and in black, that means you're typing text, you're not typing commands. In the new version, it doesn't always put this prompt in there. Like if I were to go to the bottom of the page, I'll just do H colon equals X. Okay, I don't really care about that. Oh, it did give me a new, this is called an execution group when it gives these brackets and an arrow. The new version might not always do that. You might just start out typing, I can't delete it, but it might just start your cursor right next to the edge, but it'll be italicized, so it's slanted. If it's slanted, that means you're typing commands. If it's straight up and down, you're typing text. Okay, I'll try to remember to say this in class before you ever open the video. Let's see. Okay, I want to go back to where I was. Okay, so in order to, like I haven't really left extra room for us to type that command in. So what I'm going to do is go up in front of this plotting an implicitly defined function, and I'm going to do insert execution group before cursor, and then it gives me a new place to type a command. And so then I'll do with and then plots. And you can do either semicolon or colon. If you do semicolon, then it brings up all of the commands that are available with the plots menu. And so I see this implicit plot command right here. If you don't want that blue stuff to show up, you just change it to a semicolon. Okay, and so now, as soon as you hit enter, then now if I go back and do this, now my command should work. It should actually produce a graph. Okay, and so there's my parabola, and the domain and range look fine to me. If you wanted to go out a little bit farther on the x, you just go back up here and maybe change it from -10 to 10. And you could do the same, you can change your y's. I don't know why it's not changing my x's. Okay, here's another way to change it. Normally the command would fix it and make it plot from -10 to 10. You can right click on the graph, and if you do axes, properties, it is not, okay. So it said use data extents. So I clicked off that, and then I'm going to tell it, I want the x min to be -10 and the x max to be 10. If I hit apply, it should work. There we go. Okay. And then I could change my y's. Let's see if I can fix it in the command. Usually it works. I'm quite sure why it's not working. So let me fix the y. I don't know why it didn't let me fix the x. Okay. So plotting a function of two variables. So remember, f of x, y is just another name for z. So they could also have just said z equals x squared plus y squared. So if I'm plotting a function of two variables, that means it's going to be in three-dimensional space because f of x, y means z. So I would use the plot 3D command. Instead of just plot, it has to be plot 3D. And then type the right-hand side, whatever after the equals. So x squared plus y squared. And then I have to give it ranges for both x and y, and I'll just go from -3 to 3 for both of them. So x equals -3 ... 3, comma y equals -3 ... 3. Close parentheses, semicolon. Okay, and so there's my graph. And when I first bring it up, I can't see the x, y, or z axis. In order to do that, you right-click on it. I'm going to make sure you can see this. Oops. So right-click on the graph, and then axes, I usually choose normal. And so now I can see the x. Oh, okay. It puts the y here and the x there, but it's really putting the y underneath the negative y-axis, and it looks like it's labeling the axes wrong. But if you click on it, you can rotate the graph, and so now you can see, okay, they really did put the y under the negative y-axis, and they put the x under the negative x-axis. It just looks funny when we first bring it up. But this is the x and this is the y. I often change the style of the graph as well, and that's right-clicking. I usually like to look at just the surface, but those contour lines are helpful in later sections. So surface will just give you this. It won't have all the lines on the graph, and so then you can see how it looks in the plane with the regular orientation of the axes. Okay, so that's plotting a function of two variables. Now here it says plotting an implicitly defined function of three variables. So so here it says plot the graph of the sphere of radius 2 centered at the point 2, -1, 5. So remember, for a sphere, it's x minus h squared plus y minus k squared plus z minus l squared, or whatever. I can't remember what letter we called it. So that equation is not solved for any variable. All of the variables are on the same side. So if it's not solved for a variable, then we always start out with implicit. And so just like before, it's implicit plot, but this is a three-dimensional graph. So it's implicit plot 3D. And then parentheses. So it would be, so x minus 2 squared plus parentheses y minus -1, so that's y plus 1 squared plus, and then parentheses, z minus 5 squared, squared, equals r squared, and the radius is 2, so equals 4, comma, and then we have to give it ranges for all 3 variables. So that it's radius 2, and the x is centered at 2. So we at least want to go 2 to the left and 2 to the right. So if I went 2 to the left, that would be x equals 0. I like to see negative values, so I'll do x equals -1 dot dot. So if I went 3 to the left, I'll go 3 to the right. So -1 to 5, comma, y equals, okay, so the y is at -1, so go up 2, down 2. So that would, and actually I think I'll go up 3, down 3 for all of them. So if I went up 3, that would be at +2. If I went down 3, that would be at -4. So -4 dot dot 2, and then z equals, so the 5, I really would like to see negative z's, but that's okay. I'll just go 3 up and 3 down like I did with the other one. So 3 down puts me at 2, dot dot, 3 up puts me at 8. And then end, close parentheses, semicolon. Okay, and our sphere doesn't really look that great. You can change the style to be surface. It's still a little bit bumpy. And you can show the axes, and so there you see it. So the x, I put the x-axis on the positive x-axis on the left. That's kind of weird. Okay, it should kind of be coming out towards us. So there's the x and the y and the z. So the center of the x is in front, the y is negative, and the z is up, so it makes sense that it's where it is. There is a way to make it smoother. I don't want you to, you might sometimes want to produce a nice graph. If you think it's not looking how it should, there's this command num points, so it means the number of points, and you can try maybe 1,000. The more points you use, the smoother it is, but also the more memory it uses. So if I hit enter, we'll see if it makes it. Yeah, see, it's a little bit smoother. And if I did 2,000, it should be smoother yet. Yeah, so it's starting to look more and more like a sphere. And you can show the axes. And yeah, okay. So now plot the graph of x equals 1 in the 3-dimensional coordinate system. Now, if I want a 3D graph, the commands that we have available so far that we've learned are either plot 3D or implicit plot 3D. In order to use the plot 3D command, you have to have it like solve for z. Z is some function of x and y. It has to be that way. There's no way I can get x equals 1 to be solve for z. So that means I have to use the implicit plot 3D command. So I do implicit plot 3D, and then you type in the equation of the graph, x equals 1. And even though it only has an x in the equation, you still have to give it ranges for all 3 variables. So I'll do x equals -3 dot dot 3. I'll just do all of them from -3 to 3. And z equals -3 dot dot 3. Okay, and there is the graph, and you can change the style to be surface, and then you can show the axes. Okay, and so we see that's a vertical plane that crosses the x-axis at x equals 1. Okay. Okay, plotting an implicitly defined function of 2 variables in 3-dimensional space. So here, if you just use the implicit plot command, it would plot a circle in the xy plane. Okay, but if we want it in 3-dimensional space, so we either have to use the plot 3D or implicit plot 3D command. But remember, for plot 3D, it has to be solved for z, and there's no way we can write that where it's solved for z. So that means I have to use implicit plot 3D. and then type in the equation. And then you have to give it ranges for all 3 variables, and I'll just do -3 to 3 for all of them again. Close parentheses, semicolon. Make sure you spell everything right. Oh, I guess I didn't hit enter. Okay, there we go. Okay, so again, this looks kind of boxy. So maybe I'll use that num points command equals, I'll just start out with 1,000. Okay, that looks a little better. And I'll change to surface, and I'll put the axes in. Okay, and so now we can see there's a cylinder of radius 1 centered around the z-axis. Okay, last problem to be done in 3 parts. So first, plotting a line in 3-dimensional space. And so in section 12.5, this problem asks us to find parametric equations for the line through 2, 4, 6 that is perpendicular to that plane. And then I want us to actually graph that line. So in class, we found the parametric equations for the line, and we had x equals, so remember it was x naught plus at, where the line went through the point x naught, y naught, z naught. So the x naught is 2, the y naught is 4, the z naught is 6. So x was 2 plus at. And remember, a, b, and c were the coefficients of x, y, and z. So the a is just 1. So it'd just be 2 plus t. Y equals y naught, which is 4, plus bt. Well, b is -1, so it'd be minus t. And z is z naught, which is 6 plus ct, and c is 3, so 6 plus 3t. Okay. So now to plot that, again, we want to plot it in 3-dimensional space, but we've never done parametric yet. And you can't get an equation, for a line, you can't solve for z in terms of x and y. If you do that, you would get a plane, because this is what the equation of a plane looks like. So in order to graph a line in 3-dimensional space, it has to be done with parametric equations. And so then it's back to plot. Since I want it in 3-dimensional space, it's plot 3D. When you have a graph defined parametrically in 3-dimensional space, we use brackets. So we enclose the equation or the different the components in brackets. And then you just type in the x component, which is 2 plus t. And then the y component is 4 minus t. And the z component is 6 plus 3, and then times t. And then when you're done, close brackets, comma. Now say I wanted t to go from -1 to 1. And then close parentheses, enter. I'm going to get an error message. So it says at least 3 arguments are required. So the arguments are first the parameterization of the whatever you're graphing. The second is for the first parameter, and then the third is for the second parameter. Well, we don't even have another parameter. Mabel doesn't care. You still have to give it a second parameter, which we will use later. I usually just call it S, and you can do 0 to 1. And now it will graph it. Okay, so there's my line. It's not really helping me that much. I definitely want to see the axes, so I can get a sense of where this line is, and you can rotate it. Okay, so it's above the floor, and I could actually have it, I can go back and change my parameters so it goes below the floor. So z is 6 plus 3t, so I would need the z to be negative. So it would at least have to go to -2. Maybe I'll go -3. Okay. And so now you can see it crosses the x or the y-axis, I'm sorry, right at 6 and then goes below the floor. Okay. Okay, graph the plane from the previous problem. Now, this one we are going to have to either use Plot 3D or Implicit Plot 3D. So we can use Implicit Plot 3D and just type in that equation, or if you want, this equation is easy to solve for z, and then do the Plot 3D command. I think I'll just do the implicit plot and just type it in the way it is. So implicit plot 3D, parentheses, and then just type in the equation. So it was x minus y plus 3 times z equals, was it 1? 7. X minus y plus 3z equals 7. And then I have to give it ranges for x, y, and z. So x equals, I'm looking at this graph and it's going from -1 to 3. So I'll just use that same range. X equals -1 dot dot 3. Y equals, so the y's went from 0 to 7. 0 dot dot 7. And z's went from -3 to, I don't know, we'll do 8. Close parentheses, semicolon. Okay, and so I'm going to change style to be surface, and then I want to show the axes. Okay, so there's the plane. And then now I want to graph them together because that line was supposed to be perpendicular to the plane. I would like to check my graph and make sure that's the case. So in order to do that, I first want to make sure my graphs worked. So I was able to plot both of them. Now I'm going to go back and give them names. When I do that, it's going to take away the graph. So I'm just going to call it A. So I'm going to give that graph a name. So A colon equals. Since I'm defining, I need colon equals. And now I just get this command there. But I already know the graph worked, so it's okay. And then I'll call this one B. So capital B colon equals. And now to display both of them at the same time, the command is just display, parentheses, and then curly brackets. So they're right next to the P key on the keyboard. And then A comma B, close curly brackets, close parentheses, semicolon. Okay, so there I see the plane and the line, and they do not look perpendicular at all. First, I'm going to change this to surface. Okay, and I'm going to show the axes. The problem is that look at how much space it took for the x to go from 0 to 3. That's about this, probably not half. So I see there when x went to 3, y was like between 4 and 5. So the scale's not the same on all of the axes. In order to get the scale to be the same, you right-click and do scaling constrained. And now when you look at it, when you rotate it, okay, now you can see they make a 90-degree angle. Okay, and so I just want you to do, oops, you can delete that now. 3 problems on your own, and it's just graphing. So you should be able to use what we've done above to figure out how to do these. But please ask if you have questions.